Good day, everybody. It's Evan Sneeman here for Umkhluko, Making a Difference. Today we're looking at financial mathematics, one of the first chapters for the third term of Matric, and we'll start by doing a bit of revision and looking at some of the background to some of the more important topics that will follow in the next lesson. Okay, so the first thing is I've got three examples here which are effectively from the grade 11 syllabus. The first one requires you to find R. Okay, now admittedly it's the same as finding I. Okay, and we know that we've got A equals P 1 plus or minus I to the power of n for compound interest. And in this example they are asking you to find I. Okay, so here's an example where they're asking you to work and to substitute values and to find, in this case, R, or to find I. In this second example, they're asking you to find that you've got a depreciation at a rate, so you get given the interest rate, you get given the final value, so this is actually the A value, so here is I, you get given N, and so what they actually ask you to find here is P. Okay, so here we are being asked to find P. So it's a different version of, doing some algebra to reorganize so you can find what the value of P is. The third example here is an example where you ask to find effective interest, nominal and effective interest rate. So you've got your other formula, which unfortunately, again, I'm not totally sure why you get given the one formula but not the other, but IN. Sorry. Let's go quickly. 1 plus IN over M to the power of M equals 1 plus IE. Okay, so here you've been asked to find the effective interest rate, so here you're being asked to find IE. Okay, so these, as I said, are three examples from the grade 11 text, and what I'd like to point out to you is that in these three cases we can find A just by substitution, we can find P by rearranging, we can find R or R in this the interest rate, or I, depending on how you write it, by rearrangement. But what we can't find up till now is how to find N. However, the work you did in the first term with logarithms will prove the clue, will provide the solution to this, because if I have the formula A equals P 1 plus I to the power of n, then we can go to A over 1 plus I to the power of n equals P. We can go to A over P to the nth root minus 1 equals I, and we can do some manipulation there if we're looking for a nominal or an effective interest rate. But what we're going to look at today is how to find N. And so what we're going to do is we're going to say, wonderful, to solve for N we're going to say A over P equals 1 plus I to the power of n. Again, looking at our terminology from logarithms and exponents, here is the base of the exponent. So what we therefore have is, therefore, log base 1 plus I of A over P equals n. And so what we now have is a new formula. We can work it out every single time if we want to. We can try to remember this formula, but the one thing is that this formula is not on the formula sheet. So again, we do now have a method to solve for n, and it again involves some rearrangement of the algebra. In this case, because n was a power, to get it to be a normal base, we had to take the logarithm of base 1 plus I of A over P. Okay, so now we've got this formula, we can go ahead and try to use it. And so here are some exam questions, and again, because this is a new piece of matric work, the questions are not that, these questions are actually quite common. Okay, so yeah, we've got Sandile buying a car for 180,000. The car depreciated 15% per annum according to the reducing balance method. The book value of his car is currently this. How many years ago did Sandile buy the car? So again, we are now using the reducing balance method. So instead of A equals P1 plus I to the n, all we are now having to do is realize that it's no longer 1 plus I, it's now going to be 1 minus I. Okay, so reducing balance means it's compound interest decreasing, so it's 1 minus I to the power of n. Again, we're going to go to, because this formula has got 1, 2, 3, 4, so there A, P, I, and n. Because this formula has got 4 variables, I'm going to go find 3 of them in the text. So he bought the car for this amount, so that's P. It depreciated at 15%, so that is I. To reducing balance, the book value at the end of it is that amount, so that's n. And clearly, how many years ago, so they're asking us to find n. So again, all we need to do, and the key part to it here is this first part, okay, 6.1.1. So we need to say 79,866,96 equals 180,000, 1 plus 15%. Okay, there is no 15% quarterly or monthly or any of those options. So in this case, it's quite a straightforward sum. We don't need to worry about it. They really are testing the log idea. So what we're going to get here is, therefore, we do it in steps. Therefore, 79866,96 divided by 180,000 equals 1.15 to the power of n. So therefore, log base 1.15 of 79866.96 over 180,000 equals n. Okay. Now I am aware that some people might not have the fancier calculators, so please recall that this is the same as saying log of 79,866,96 over 180,000 all over log of 1.15 if you needed to. Okay, so this is only if you need to. Okay, but here on the left is the preferred method, so I'm going to continue with it. And what I want to tell you is that this here is actually the more important line. Okay, so as you can see, this is worth 3 marks. This line is worth 2 of the 3 marks. This bottom one is only worth 1 of the 3 marks for being able to use a calculator. Okay, so actually the more important line is that line up above, the log base 1.15. So let's have a look. Log base 1.15 of fraction 79,866.96 divided by 180,000, okay, equals, on this calculator, I'm getting an answer of, it's kind of weird, okay, okay, I'm getting an answer of, therefore, n equals, sorry, wrong color, therefore n equals, oh, okay, again. So what I want to point out to you quickly is, again, I've made a small error here, and we can fix it quickly. But again, I got an answer of minus 5,814. And again, this is not what I intended to do with you today. I didn't want to make mistakes with you, but I'm actually quite pleased that I did make the mistake. Because how can the number of months be negative? This does not make sense. Okay, So although I am cross with myself, okay, I'm actually quite pleased that I did make this mistake, because it can illustrate to you that actually, although I'm doing a sum here, my sum needs to make sense to me, okay? And we can't get a negative number of months, okay? That would mean we're working back into the past, or I'm not sure, quite before the Big Bang. I'm not quite sure how you would make sense of a negative number of months, okay? So again, what I need to realize is this answer not making sense means I should probably go back and check my work. And what I'm seeing quite quickly when I do check my work is, oops, I made the cardinal error of not copying down my formula correctly. And the formula over here says 1 plus 15%, when I hope you were shouting at me right from the start that this should have been 1 minus 15%. And so that therefore is not 0.15. Okay, sorry, wrong. That's not 1.15. Okay, and won't be in any of these cases here. Okay, it will be 1 minus 15%, so it will be 0.85. And when I put this in now, I no longer get the answer of, okay, just quickly going through on my calculator here, possibly just slightly off screen for you, 0.85. I now get an answer of, good, a much better answer now. You can see that this answer is now not working. This time around I get an answer of n equals 4.999, lots of nines, okay, another couple of nines. And so we're going to say therefore n is 5 months. Okay, so an apology sincerely for the mistake, but I think that making the mistake was able to show you quite importantly how even though we're working, we are still tracking our things to see if our answers make sense. Because again, what is nice about finances is that it is the most realistic, or probably the most real world application of mathematics that we are going to do in the matric syllabus. So it should make sense, okay? So if he bought the car now for 180,000 and a couple of months in the future it is worth 79,800, the answer can't be a negative number of months, okay? So again, please do check your work as you are working through the paper. Okay, so 6.1.2, a follow-on question. Okay, so no surprises here. There's a follow-on question, and this one says, oops, let's just see if we can get some space here for it. Okay, cool. At the same time, Sandile bought the car, and Neil deposited 49,000 to thing at a rate. Okay, could he buy the car now? So let's have a look. Okay, so he put 49,000 into the account, so that would be P. That would be a P value. Okay, he decided his account at an interest rate of 10% per annum. Interest rate compounded quarterly. Important that we realize that the time period here is going to be quarters. Okay, and he's done it for, okay, at the same time that he bought the car, so he's talking about now, so he's talking about 5 months later. Okay, so sorry, not 5 months, I'm being silly, really silly. It's not 5 months, again, not quite sure, I'm making so many careless errors. 5 years. And so following on for Anil's question, we get from this question over here, we get that n equals 5. Okay, so again, we spoke about this before. The bulk of the marks is actually for this first question. Okay, this time we are increasing in value, so we know it's going to be a plus sign. So we got that Anil put in 49,000. Okay, 1 plus 10% divided by 4 to the power of 5 times 4. Okay, so therefore I've got 49,000 times 1 plus 10, and I would really encourage you to try to use the percent symbol on your calculator if you have that, or if you have that option. Okay, and just literally type it in as you have got it, being raised to the power of 5 times 4, and I'm getting an answer of 80,292 Rand. And a couple of cents, 21 cents. So question, would he be able to afford has he accumulated enough money? Well, we are comparing this to the 79,000. So this value is bigger than the 79,866 that Anil's car is worth. So therefore, we would answer, therefore, yes, Anil has enough money. Okay, so again, what I'd like to show you here is that the question was not too difficult, okay, but again, it was a question that required a log to solve it, and as I said to you, that's one of the key concepts here of the matric finances, even though it's one of the easier parts of the matric finances. And the second thing I'd like to speak to you about is, please do check your work as you're going along. Don't only wait till the end of the exam to check your work. See if your answers do make sense to you, especially in the finances chapter, which is a practical application of mathematics. Okay, so moving on to question 2. I think I had another one. Okay. So the next question I want to look at with you is a question that arises quite a lot, although I couldn't find any exam examples. I see it very often in the exams. Okay, but how long does it take money to double at? Okay, so how long would it take an investment to double at, let's make it 12% per annum compounded monthly? Now, many people would come along to this thing and say, well, hold on, we know that we need to use the formula A equals P1 plus I over M to the power of N times M. Okay, we can see that there is a keyword monthly. We can see that I equals 12%, but oops, where's A? Where's P? Okay, these things aren't obvious right now. Until you understand what this word double means. And what this word double means is that A will be twice the size of P. Okay, now you are welcome to make P equal to 10,000, and therefore A is 20,000, or anything along those lines. Okay, but you'll see that actually doesn't make a difference what value you make P equal to. Okay, so I often tell my kids to suck their thumb and to just make up a value. Okay, because you'll see how it pans out now. If I plug these values in to this formula, I'm going to get 2P equals P 1 plus 12% over 12 to the power of N times 12. Okay, so what's going to happen here is, let's have a look here. Okay, so we're going to say, wonderful. The first thing we're going to do is we're going to divide by P. And if I had 10,000, 20,000, the same thing would happen. I would get 2 equals 1.01 to the power of 12n. No matter what happens, when I divide by this P and I bring this P over, I'm always going to get 2. So were I to choose 100,000 as my P value, or 10,000, or simply the number 1, 2P divided by P will always end up equaling 2. Okay, so the key thing here is to understand what this word double means, for double, I suppose, in Afrikaans, and to understand that that means that no matter what happens, when I divide the A value by the P value, I will always end up getting 2. Again, I'm looking for a power, so I'm going to take the log. So therefore, log 1.01 of 2 equals 12n. Okay, where n is the number of, potentially the number of years, or the number of, okay, so let's have a look. Log base 1.01 of 2 equals, so it says to me that 69.66 equals 12n. Well, what you need to realize is that that means it's going to take me 70 months, Or if I was to divide by n, it would take me 5.8 years equals n. Okay, so it would take money 70 months or 5.8 years to double at the interest rate of 12% per annum compounded monthly. Okay, so as I said, this question occurs a lot in textbooks, and I haven't seen it too often in examinations. But again, please look at the method of how to reduce the 2p, the unknown a, okay, by letting it equal a variable. Okay, so there was the key skill here was letting a equal to a variable. Okay, if you are comfortable using variables, alternatively, you can simply choose a p-value and as a result get an a value. The key thing is to plug these into the formula. Okay, do some algebra to isolate the variable you're looking for, and then to interpret your answer. So again, if I was to try and make notes for you, the notes would go something along the lines of identify the correct formula, identify the variables in the text, substitute the values in, isolate the variable you're looking for, so isolate the unknown, and then solve and interpret if need, and interpret or make sense of it. Okay, so again, what we have here is a set of rules that work pretty much every single time, and they will even work for the more complicated work that we're about to look at next week, or in the next, sorry, not next week, in the next lesson. Okay. Is there anything else I'd like to comment on from these two examples? No, but again, just as I said before, we did the exact same thing here. We identified the correct formula. Admittedly, initially we substituted into the wrong formula, and that was a cardinal error. Okay, but having substituted our values into the correct formula, we isolated our n value using a logarithm, which is our new work, got an answer and interpreted it. And the way we were able to identify that we'd made a mistake was that when we tried to interpret it, it didn't make sense to us. Okay, so we then used our time to go back and check, knowing that this was a practical application of mathematics, and therefore the answers should make common sense. Okay, so 5 years was very nice that this thing rounded off so nicely, 4.999999. Okay, I think we'd all agree that that is pretty close to 5 years exactly. Okay, next week we'll look at a little bit more interesting maths. It does ramp up quite significantly before the next lesson. Okay, thank you very much.